The Demise of the Dinosaurs by Monica Trudy. The KT event, or known as the Cretaceous Tertiary Extinction Event, occurred about 66 million years ago. It's a sudden mass extinction of 3/4 of the plant and animal species on Earth, including dinosaurs. For many years, paleontologists believed this event was caused by different changes that interrupted the dinosaurs' food supply. So, paleontologists proposed several theories for this event, yet it was difficult for them to prove. One of the earliest theories was that small mammals ate dinosaur eggs, reducing dinosaur population until it became unsustainable. Another theory was that dinosaur bodies became too big to be operated by their tiny, small brains. Some scientists also believed that a great plague killed the dinosaur population and then spread to the animals that feasted on their dead bodies. Starvation was yet another possibility. Large dinosaurs require large amounts of food and could have eaten the vegetation in their habitat. So the scientists thought, well, if dinosaur brains were too small to be adaptive, they wouldn't have lived for 160 million years. Also, plants don't have brains, nor do they suffer from the same diseases as mammals, so their simultaneous extinction makes these theories less credible. Now, the Earth cools in periods called ice ages. As dinosaurs were thought to be cold-blooded, they would not have been able to survive such cold conditions. Many scientists propose the climate change or the ice age theory. But some cold-blooded animals, such as crocodiles and lizards, also survived. Climate change would have taken tens of thousands of years, giving dinosaurs time to adapt. So, we need something else. Well, did this come from outer space? And why would I say that? Well, in 1981, Lewis and Walter Alvarez, father and son, discovered a centimeter-thick layer of iridium-enriched clay at the KT boundary. These different sediments that you see here show different eras and points in history. You see that the iridium layer is marked in yellow, and it is a lighter segment in the sediment. Well, iridium is rare on Earth, but more common in outer space. They found that the thin layer of iridium had to be a result of the impact of a large meteor, comet, or asteroid with the Earth. As time went by, other scientists began finding iridium evidence at different places around the globe as well. 29 years ago, a massive meteor crater, 110 miles in diameter, was discovered on the edge of the Yucatan Peninsula, extending into the Gulf of Mexico, named the Chicxulub crater after the nearby city. Scientists believe that the asteroid impact that formed the crater was roughly 6 miles in diameter, struck the Earth at 40,000 miles per hour, and released 2 million times more energy than the most powerful nuclear bomb ever set off. So if you look here on the picture, that red dot is where the crater center is where that asteroid hit. Then it created 2 rings after that impact, and you'll see that they are named here with a white dashed line. So what possibly happened after the asteroid hit the Earth? The heat from the impact would have broiled the Earth's surface, ignited wildfires, and immersed the planet into darkness as debris clouded the atmosphere. Tsunamis would have washed over the continents, drowning many forms of life. Shockwaves would have triggered earthquakes and volcanic eruptions. Darkness could have lasted for months, possibly years, and set the Earth's temperatures into freezing zone, killing plants and leaving herbivores with nothing to eat. Many dinosaurs would have died within weeks. The carnivores who feasted on the herbivores would have died a month or two later, and only those small scavenging mammals would have survived. And there we have it. The iridium layer plus the Chicxulub crater were enough evidence to convince many scientists that the asteroid impact theory was credible and is today with this KT event.